Okay, so welcome Sunita Sundar from Texas, USA, who is an alumnus of Pilani and also from the University of California, San Diego. She has been in the industry over the last more than a decade, and she is concerned with process safety and mechanical integrity of the refinery and oil business, etc. And see, safety, process safety is much more than just saving lives. It is also taking care of the health. Cooking कर दो, हाँ. Process safety is just not for preventing accidents. It is also to protect the health of the workers, right? Um so a lot goes on this, and today being the World Health Day, we are lucky as chemical engineers to have a process engineer who is concerned with process safety and health issues in the industry to give a briefing on what this is all about. Thank you, and I welcome Sunita to uh, take over and talk to our students. For the briefing, I must say that Banasthali is a women's university which was established in 1935 as a school and then grew up to high school, college, and then became a deemed university in 1983. So it's almost going to be 90 years of existence for this university, and it's a fully women's university, and it's about 1,000-acre campus, and there are 18,000 girls studying in this university. Right, there are 18,000 girls. For a Bitsian, I must say, there are 52 Meera Bhavans in this campus. Okay, so that's it. And I have been fortunate to have had good students like you who were very, very regular in attending all the classes. I need not take, attendance. I know by looking at the face that all these people are present in the class. So wonderful. And today, I will be hearing the lecture from you. Okay, thank you and welcome, Sunita. Come, everybody, give a big hand. Yeah.
So good evening to everyone. It's around 7 o'clock for me. It's a Sunday, so bear with me if I'm going to yawn in between. So first of all, I'm so glad that Professor Nattu sir. That's how we fondly call him. To have invited me for a lecture. I know he's been asking me for a long time, but it never, it never manifested. It never worked out. But I'm so glad it finally came together, and on a special day, which is a World Health Day. So happy World Health Day to everyone. I'm going to share my screen. I have a small brief presentation, and I'll talk you through process safety as much as my knowledge has. And then I know Nattu sir is there, and you all can reach me out either on LinkedIn or email that I'll provide later at the end of the talk. And I am also very glad that Nattu sir has taken this, position as as an instructor or for Banasthali University, especially, which is like a women's university. And then it's my pleasure that I'm going to be motivating most of you because I am a woman and I know how difficult it is to be in a core industry. I'm glad you're all pursuing chemical engineering, not the regular IT. And I hope I can give some amount of my knowledge to you all. I'm trying to share. I'm going to share my screen. Let me know if you all can see. Sir, if you just confirm that you are able to see my screen.
Yeah, you are able to see the PPT.
Awesome. Okay. So today's agenda is yes. So Nattu sir, he gave a good introduction of my, my background. So I am a chemical engineer from Birla Institute of Technology and Science with Pilani, and I came to the US and I pursued a, chemical engineering masters in UCST. I did work for about two years in the IT industry, but I realized that I think chemical engineering is my heart, and that's where I wanted to continue. So I moved on to the chemical engineering field. Post that, I started as an integrity engineer in the oil and gas, and it's been about 12 to 14 years now. I've been, the regular process engineer, mechanical integrity engineer, and process safety engineer. So I'm going to go over a safety moment, and then we will look into the PSM, which is a process safety management. It's a whole framework, and then it's mainly by the OSHA Association. There are about 14 elements. I'm going to try to do my best to cover, brief you all about all the 14 elements, but there are a few that I have worked on, and I have a little bit of experience and, some case studies, not case studies, but then my experience, what I have worked on. And I thought at the end I'll give you all some information about what the opportunities are in the field. So, if you all want to pursue something, there are umpteen opportunities for women in this field. So, I think it will help you all to make some educated movements going on. And then any question answers you have. So let's get started. So happy World Health Day to everyone here. So when we start or talk about safety, right? So plant safety, process safety, there are like people, process, and procedures like plant there, right? So first thing is we need to take care of our safety, which is the personal safety. And I know like summer months have started in India, and so even in Texas, Texas is supposed to be very hot, as hot as how you have in Rajasthan and other states. So first, take care of your health. Heat stress is something we usually ignore because we tend to get worked out. We get very busy with our work and everything. So the summer months are there. You're very prone to stroke. So try to wear loose fitting clothes. If you are in if you're in an AC, you're fine. But if you're working out in the field, you have to walk around. Wear loose fitting clothes. Try to go for cotton clothing that's going to absorb your sweat. So you don't heat up your body more than the natural surroundings. Use some sunscreen or anything that you can protect against, an umbrella, cooler, something that's going to protect you from the heat. Drink plenty of fluids. This is where like most of us lack. I would suggest keep a water bottle all the time. Make sure that you keep drinking water. And my indicator is, if you get up in the morning and you go for a pee, your pee has to be transparent. That's when you know that you are not dehydrated. So drink plenty of water, fluids, keep yourself hydrated. If you have any medications that you're on and that's going to aggravate your heat issues, then take that on time. Don't prolong, don't postpone and say, oh, it's after all a medication, but then it's to help you keep your body working in a working condition. So in our case here, we heavily use cars, right? So we make sure kids are not in the car. You don't leave anyone in the car. Like, say I just want to go get something from the grocery. Don't leave anyone in the car. Take them with you, because you never know when the temperature inside increases, right? The ambient could be at a temperature, but inside it's going to be hotter. Take it easy during the hottest parts of the day. If you think that you can do work from a part that's cooler, go for it. If not, follow the other things, drinking fluids, keeping your clothing light and stuff like that. Because if you're going to be working elsewhere in a plant, there is no way you're going to take off. You still have to work. So then where you wear the appropriate clothing, you keep yourself hydrated. And be cautious if you're at increased rate, like if you're a little older or you think that you have certain medical conditions, be aware of that, be cognizant of that, and then take the appropriate necessary actions for you. So keep that in mind, and always keep emergency numbers in hand. This is something even I myself have failed to do. Like, when the last situation comes, that's when you go running around, oh, where do I call this? So like maybe an emergency. For us, it's a 911 number. For that, if you have an ambulance number or you have a close relative, always keep them informed. Say, hey, I'm here. Today seems to be a little hot, so just keep a tab on me. Not keep looking at the phone all the time, but just to keep a tab that, okay, everything is going good. And there is someone to, make sure that you are also okay. So that's about personal safety. I also wanted to talk about personal safety. So being in the industry, when you're out in the field, like you're in the plant, you're in the like you're offshore or anywhere, your safety is the key, because you're the one who's going to be working, right? If you are not equipped and if you are not safe, you're not
Can we
going to.
connect a minute, Sunita? I think if
Yes.
you are changing the slide, we are not seeing the change in slide.
Oh, you're
Because,
not?
yeah, you put
Oh.
on slideshow, we will
Now?
see only the first slide.
Oh, okay. Interesting. Hmm, how do I?
slideshow and share, I think.
Yeah, I did that. That's what I did. Entire screen. Let me do. Now, let me do a trial. Now
Yeah.
it changes.
Abhijit, dismiss.
Now can you see it?
Yes, yes, yes,
Perfect.
yes.
Awesome. Okay. So I just went over the personal safety. Now I'm going to move on to personal safety. So let me come back. So typically when we work in sites or when we are even in the regular office, right, there are certain personal safety that the site, the corporate and everyone wants you to follow, so that in spite of knowing that you are in like a little dangerous or like a little offset environment, you can protect yourself first, like how they ask you in the aeroplane, right? First you get your oxygen monitor before you're going to help others. So before you're going to help your clients or your plant or your the other aspects, first you take care of yourself, right? So that's where the personal safety comes. So some personal safety equipments that we typically use in the industry are like a flame resistant coverall, hard hats, your steel-toed shoes. They're just super heavy, but then they are very important, because if you have any fall or dropped objects, it's going to protect you from that, especially your hard hat and then your steel-toed shoes. Then you have, they typically in environments where they think that you have H2S or CO2 that could be in the process, they give you a monitor. And then every morning they give you the monitor, they calibrate you in the office, and then they send it. So make sure when you start working, you ensure that you ask for it. If they don't give, hey, is this site, be aware of your surroundings, is the site having anything like that, should I be using it? So have it all the times. Eyeglasses, oftentimes this is neglected. Oh, it's after all a glass, I have a hat, I have everything, it's not going to. No, keep it, because you dust particles, sometimes things that is not visible to the naked eye, that could get into your eyes, and you never know what could go wrong. Because when I was working in my first job, I had a colleague who was working on like a like a clean process, where he was looking into stuff and he was grinding something. He was wearing his regular glasses, or maybe he maybe didn't wear it. A small chip of the thing just went into the eye, and then he had to go through some medical situation. So nobody knew that it was going to happen. So always wear the safety glasses. And the other, sometimes in the real industries, you have big towers, tall towers that are like so big. You sometimes you are in the offshore field, like like a platform which is in the middle of the sea. You're going to be working above water. Make sure you have your safety harness. You go through protocols, you don't miss any of those things. Rope and ladder safety, not only in the industry, even at home, we tend to just neglect that. We say, hey, it's just close by, I'm just going to go. No, there is a limit that you can start. Have another person hold the ladder. You go there only then, because you never know when something is going to go wrong, and then it could just become catastrophic for your life, right? Fire extinguisher use at home, at your office, at the plant. Learn how to use it, because it's there. We know it's there. We take credit. Oh, it's there, so we are good. But at that last moment, when you don't know how to use it, there is no use of relying on an asset that's going to be there, that's helping you. Typically when we get into the plant, right, we use safety orientation at the sites, just to understand what that plant is, what that facility is, where do they expect issues going on, where you have safety showers, like for whenever something goes wrong, you have safety showers that's going to help you with your eyes. Fire extinguisher points, muster points, like if there is an emergency, where everybody starts collecting, or where they like you come and pool yourself there. Do a job hazard analysis, even at your own, like if you're going to a new spot, take a quick run. Oh, I think this is like, sometimes you have wires. Say you're working in an IT office, wires, or you have some seats that are coming out, or you have something that's hanging. Maybe you have stacked stuff that's going to trip somebody. These are all, and then you see people not holding rails while walking. These are all your analysis that you do at a job site. Just a quick thing, and keep it in mind, and then educate yourself, and if possible educate the facility. Hey, this looks like a trip hazard, this look like a fall hazard, this is a slip hazard. Do you think we can eliminate that, so that everyone is safe? job safety form. So every day in the morning when we go, we ask our engineers or our inspectors that, hey, every morning make sure you have ticked everything, your personal safety, your site safety. So at the end of the day, there is nothing wrong going on. So, so personal safety and personal safety is key whenever we are in the industry, because we first want to guard ourselves before we get into the, into the doing and helping others with our knowledge and our services, right? So, is there any questions or anything anybody wants to add? Nattu sir, do you want to add anything on that front?
Uh, Not really. Actually, our campus is very close to a Indian oil unit, which is a storehouse of crude oil, which comes
Uh-huh.
from the Gujarat port.
Okay.
And the pipeline is a huge storage farm here in uh, a small village about 20 kilometers from our campus. And from there, the pipeline bifurcates into Mathura refinery and Batinda refinery, Panipat refinery, for the feedstock. So actually, we are one of these days we are scheduled to visit there, and they also gave an idea about the preliminary safety issues which have to be strictly followed when we visit
Yes.
them.
Yes. Take it serious and then go with it. So you can be proud that you
We will,
first
we
we
will.
follow before we preach, right? So
Yes, yes.
awesome, awesome. So so now I'll just delve into the topic without further delay. So process safety program is something that I've been involved with. Though I'm a mechanical integrity engineer, the integrity is also one of the elements of the process safety program. So what is process safety? So it's a discipline framework for managing the integrity of operating systems and process handling hazardous substances by applying good principles like in design, engineering, and operating practices. So I, to me, I've worked in the US for a long time. So you will repeatedly see me talking about OSHA, but there might be counterparts with for India. So if you can Google, but the strategy, the aim, the principles are all the same. To have a safe environment for the assets as well as the people. So there were like before 1990s. I mean, in the early 19 and the late 1990s, there wasn't any particular framework where they could actually follow process safety principles. People were running the plants. They were still running, but then there were so many injuries, so many deaths, and then it was not looked into. So all of you would have heard about the Bhopal tragedy, right? I'm not going to elaborate on it, but then the methyl isocyanate unit, there was a leakage and explosion, and then when the investigations and everything was done, what it all boiled down to was just substandard procedures and unstaffed plant. Similarly, you all have heard about, like, if you're in the chemical engineering like industry and you're very much into it, you'd have heard about the like some of the examples are here, but the deep water horizon of BP, um, just simple cost cutting. What do they do when they cost cut? When everything goes down, cut down process safety initiatives, reduce the staffing, you don't look into the safety of the systems, maintenances are delayed. So safety systems were inadequate, and then it all led to ignition. And very less heard of, but then one of the key incidents that actually led to the OSHA process safety management framework come up was also the Chernobyl disaster. So it was a nuclear power plant. As simple as a coolant pipe rupture, it resulted in, like, issues, and then the investigations found out that just operator actions and design of the reactors were the key that went wrong. So how can we actually reduce this, right? It's You don't want to go to your site in the morning and you don't know if you're in a safe environment and come back, whether you'll even come back, because you have loved ones. Eventually, I mean, at the end, you're earning for coming back to a safe family and have a safe environment to work with. You don't want to keep thinking 24/7, oh, when is this reactor going to burst? When is this pipe going to burst? When is this going to go? If that's the case, there will not be anybody working in hazardous materials, and I think the whole world will not even function, right? I know there are situations where we have hazardous. So to keep a safe environment, that's where the OSHA process safety management framework came in. So employers, their basic thing was to cover the employers to make sure that you have a safe environment. and also to make sure that the processes, the assets like your reactors, your pipelines, your instrumentation, they're all safe. Because, say for example, why do you think you're safe in your house? Because you know you have your doors, you have your windows, you have a lock. Say you're not maintaining your doors, your windows, and your lock. Do you think eventually it's going to help you? Just one thing, and then it's going to just fall apart, right? So there is a whole process for you to keep, so that you maintain it. Then you can take conviction or credibility of that being a safeguard for you. Similarly, in your plant, right? You just can't install the entire plant and say, okay, I'm not going to take care of it, I'll go work every day. No, you have a lot of things. You do inspection, you do testing, you do maintenance activities. You periodically go check what are the additional hazards. Am I looking at something over there? Is something going to go wrong? Is everything okay? Say I have a pipeline, I have installed relief devices that's going to help me. Hey, is the relief device working? Is that pressure indicator giving me the right reading? Is it calibrated correctly? I have been functioning. Say you have a fluid going in. Do I have any corrosible materials that's coming in? Because I'm only designing the pipe for the clean material for the given specification. But over time, things can change. You might have a shutdown. You might have some, ingress of toxic chemicals or corrosive chemicals coming in. You never know, because your feedstock is coming elsewhere. You're running. So constantly, you have to evergreen the process. Constantly keep looking into it. Evaluate it, and then determine what are the action plans. Sometimes it's preventive measures. Sometimes you have to also list out your mitigative measures. So that's what the whole process safety, element itself came into picture. So the PSM standard, it requires a comprehensive management program that integrates technologies, procedures, and management practices to help ensure safe and healthful workplace. That's what I'm like talking about, just coming from what I have worked with. While the PSM standard has been effective in improving process safety and protecting workers from the many hazards associated with uncontrolled releases of highly hazardous chemicals, major incidents have continued to occur, which is very true. We've been in the industry. This has been almost like 40 years now. We still see issues. We still see issues even at the design stages. There are, cost cutting or lack of awareness of the regulations, your compliance, your codes is still there in the industry. That's why I think people like us come into it. So, maybe 20, 30 years from now, it gets even better. Every company has a policy of zero fatalities, zero safety incidents, but it gets time to reach there, right? So, moving on. So, like I said, the OSHA PSM, it has 14 elements. So, typically they are, graded into like risk assessment. Some of those elements that help in controlling the work, and then some which are in the health and safety management. So, like you can see, the process safety information, process hazard analysis, operating procedures, they all usually come into the risk assessment section of the OSHA, the PSM 14 elements. When you want to control work like hot work permit, emergency preparedness and response, mechanical integrity, it's all like how your daily day-to-day work goes, like pre-startup safety review. And then touch points with the personnel, like people like us who are working in it in the field, contractors, inspectors, engineers, is the health and safety. Like you come with contractor management, incident investigation, if there is any change, management of change, is there any employee involvement, and trade secrets. Like some companies have trade secrets, but then still you are supposed to disseminate some information based on what is covered within the framework of the PSM program. What I'm going to do is try my best to brief you about each of these elements. And then when we culminate into the 14 elements, and I will share with you, where I have worked, how it has, helps in averting risks, and, and then what kind of opportunities you all have working in all of these. So the first thing is employee participation. So like we said, it's World Health Day. We need to take care of ourselves. We need to keep ourselves engaged. We need to be aware of it. So say that you're getting into a facility, right? If you are not aware of your surroundings, if you don't know what it is, if you don't know what they are, like what you're doing, what the process is, how things are spread out, where exactly things are, it's not going to help you. I can have hundreds of procedures there. I can have hundred of action items. I might have an emergency response. I might have a management framework. My corporate will have compliance. But if you are not aware of it, what's the whole point of it, right? Because something goes wrong, hey, I need to go check in this. This is how the protocol is. For example, if there is anything and then there is like a muster point, I don't know. I don't know what to do. Or there is something that's like there is something leaking. What is your protocol? Okay, stay away, stay, stop work. Like we say, stop work authority. If anybody around, like say you have colleagues that you're working, or other plant people, right? Or other facility people, even in your IT office or any other industry. You see there is a situation that's hazardous. You have a right of authority to stop it. Say, hey, stop it. It's not worth continuing just because you have to do it, because your safety is important. So we always call it a stop work authority. You document it. You say you stopped it because no, I felt this environment was unsafe, right? Similarly, employee participation is very key, because we have training. We keep, we refresher trainings. We refresh our documentation procedures. We find some things that we have to implement additional stuff, but at the end you have to keep everybody informed. So you train them. So every touch point and all the rest of the 13 elements, we have employees there. So they are the key. Then going into process safety information. So I know you've been studying like chemical process technology, then a lot of other material balance, heat transfer operations, all those things. Where does it all culminate into in the industry? This is where. So you have a process, you start adding toxicity information, reactivity documents, temperature, pressure, what is your flammability limit, what is your upper explosivity limit, your lower explosivity limit. Say you have a hazardous materials, it's not going to be hazardous at all situations, right? There are the fire triangle. A fire triangle happens if you have a source, if you have the ignition point, and then you have the oxygen feed. So if one of them is cut, it's not going to happen. So what are all the things that's going to result in a situation that's going to go out of control? And UNA equipment documents, like it, if I have a pressure vessel, they say it's called a UNA form. It will talk about what I have, the tubes I have, what is the material made of, what is the maximum allowable pressure I can use for it, what's the temperature, what is the manufacturer data record, what kind of pipe specifications, thicknesses, lot of things. PFDs, PNIDs, key. Every process, without the PFD and PNIDs, we do nothing. Material flow diagram. So material flow diagram is where you start, right? Just a block diagram, which I remember, just a simple block diagram you start off. But then it goes into a process flow diagram, which gives the entire plant with the key assets like the reactors, towers, materials, and then further detail every line, every instrumentation, every like a pressure relief device. All those information is key. Where we actually see the biggest challenge? All, I would say 99% of the industries, they don't have anything. They don't have all of these updated. They have one set of information, the other is missing. So we still need people to make it, evergreen, to come together to make sure it's all in place. Because say for example something is going wrong, you want to evaluate a situation, like, hey, I have maybe maybe I have a carbon chlorine material going in. If I want to evaluate the hazard, I need to know what temperature is it going in, what is the pressure you're looking at. If it ruptures, what is the flow that's going to come out? What do you think? Do I have an ignition source close by? Or if I say, for example, if it's an ignition material, do I have a source close by? At what contact or what point it's going to rupture? What it is going to turn into an explosion, fire? All this information, when will you know? When you have the layout, you have the information about like the temperature, pressure limits. If you don't have any of this, how are you even going to do a complete qualitative and good evaluation? You can't. You are only going to do it with an existing, and you won't even know if it's going to help you at the end, right? So then what we actually do is process hazard analysis. So I personally have been sitting in hazard reviews, low power reviews, hazard reviews, right? Across the life cycle of a plant, anywhere from design, they call it a design hazard. When you're designing a plant, you talk about your materials that you're going to select, what type of processes you're going to select, what type of process fluids you're going to use, what are the temperatures you're setting, what is your yield, etc. Right? Even at that stage, you can do a process hazard analysis. So what in a process hazard analysis, what do? You just say, hey, I have this process. What kind of hazards am I going to look at? Say if there is this pipe, it's going to rupture. What am I going to see? Is if the temperature is going to increase at this point because a particular valve is closed or something is closed. Just because I'm using this particular material, what are the hazards that I present? So you look at the worst case scenario, you document it, And then if you say, hey, I don't think this material seems to be, compatible, there are better materials in the industry, why don't you go for a safer design, safer process, reduce the inventory. Say sometimes they have like lot of big tanks stored, why don't we reduce the storage? That will inherently reduce your hazardous situations, right? So those are the things that we discuss. That's the design, right? Then you go into the front end engineering design. After that, you go into the construction phase. When you're in the construction phase, you typically know, okay, it's the design is done, we get into this phase. So now let's look at it. Then you go into, before you set it out into operation, so they call it the pre-startup review. As so there you do a full segment, make sure, okay, everything is good, this is what we discussed, do you think it was implemented, were there any recommendations, were there any changes to the code, where anything new was added, any new protection layers that were needed before you start. And then starting a plant is it's a big thing, because it's a big thing. You don't know, even at a small stage, anywhere down the lane something could go wrong, right? So the best thing that you can do is do your hazard analysis before, keep everything ready before you're going to start. Once you start, you have to maintain the plant. It won't run on its own, like every 5 years or every 10 years, or depending upon if you have any issues that comes up, you're going to maintain more, you're going to turn off, shut down, do normal checkups, walk around, things like that. So that's the process as our analysis. So typically we have like 3 to 5 years we renew it. So we already have, we revalidate for a running facility. And then has a usually PSM, we call it PSM covered and PSM non-covered facilities. So PSM covered facility means that there is a minimum inventory of a hazardous materials that that particular plant should carry for it to do the PHA and come into the PSM regulations. So some of the typical types of PHAs we do is like hazard identification, just a simple checklist. If it's a very simple operation, if you have a very complicated operation, you go into a detailed study like layer of protection analysis, hazard operability, and different softwares have come which like make your life more easy to document than using the traditional Excel sheets and stuff like that, right? Like PHAS, PHA Pro, most of you would have heard about it. So moving on to operating procedures. So it's very extensive. It's a very boring activity in my thing, because you have documentation. That's very important, because every operator, everything you cannot, make it digital or make it automatic, right? There are still operations in the industry or legacy operations, older facilities that don't have the bandwidth, or they can move into automatic things. So you still have people who have to operate, like every 3 hours you have to go turn this valve, open it, make sure this is the thing. Oh, if you see an alarm in your operator room where, okay, I think the high level has come, I need to bring this particular open this valve, or I need to shut this off, things like that. But how do you know what is the time response? Say I'm sitting here, I see something, I'll say, okay, I'll wait another 15-20 minutes and go. No, maybe that's not the time frame. It's going to fill up fast depending on what the flow is, right? So all these things are typically put there. And then they'll also say, hey, if this is the time response for this, and for certain things, the person should be there within this minute. For this kind of processes, every 10 minutes or every 3 hours, you need to make rounds. This kind of protective equipment is required in this. So these are all the operating procedures that are there. And usually, right, in the plant, we have regular shutdown maintenance, but emergency shutdown happens. Non-maintenance, sometimes they'll have to shut down a part of the plant. But when you want to start back, there is a list of procedures you have to follow. You just cannot crank it up back, right? Because upstream and downstream, it's going to affect. So even a small change could result, like it will just add on progressively and result in something hazardous. So operating procedures are very important. Moving on to the next, training. So like I had mentioned, the first thing was employee participation. So how can you keep your employees on par and abreast with all what's going different? So you have training, PSM, on the PSM policy. What is the strategy for the company? See, you have different levels of people, right? You'll have corporate, which is the higher HR people or the compliance people, the directors. And then you come into engineers who are with the plant. Then you have the people right in the plant, the operators who are working, inspectors who are in touch phase with the equipments, the plant, the processes and everything, right? So each of them require different type of training. You can't give a simple training to everyone, depending on their role, their responsibilities, where they are, what are their touch points. So a customized training is to be offered. So say I'm only giving the training at the beginning, what's going to happen? It's going to change because your facility is aging. your things have changed. Sometimes you change your materials in there, you change part of your processes. Sometimes they retrofit. What they do is they have an existing plant, they'll say, hey, I'm going to add this new process to it. That thing will a totally new process, right? If the people is not aware of it, you don't know how to respond to it, how to actually act around it. So there is a requirement that every so many years you have to do the refresher training and maintain records. Say I have 50 operators. Hey, this operator, he works in this particular unit. Say he works in the demon unit. This person, he works in this refrigeration unit. This person works in the ammonia unit, urea unit. They require specific customized training. Okay, they are done. Okay, next year we will do it. So keep a track of it. So when we get back to it, we know who is covered, who is not. But I tell you, this is all great in paper, but we still struggle in even a big company to keep track of it, to actually do it. Then you go into contractors. So third party inspection. So not everyone is within the company. For a lot of activities, we have people coming out. For example, if you look into a NGL facility, you'll have truck drivers coming in with carrying lot of liquids, the gas liquids and all those things. They'll just come, they'll connect the hose, they will fill your tank. For even in your regular like your petrol stations, what they do, they come in with like they come in the big tank lorries where they have all these information, they just connect it, right? You need to know if that person is educated, he's doing the right thing. Because simple things like putting the hose into the wrong thing, it's going to become a disaster. Because when we were discussing in a PHA, they were like, how can we actually even customize the hose design, so that say I have a particular reactive material A and reactive material B in the same plant, A will only go into this tank. It will not fit in any other tank. That's a very simple way of design, right? But that's going to eliminate a lot of things, because you don't know where he is going to cook. In his tension, you might have a new driver coming in who doesn't know, and not everybody follows all the protocols, right? Say that person is not trained, like, okay, both the tanks look similar, I'm going to hook it to anywhere. You never know what is going to go wrong inside, right? What if you have two different reactive materials that don't go together? You're going to result in a big catastrophic event. So simple things like that. So when you have third party people come in, they need to know what your site is, what safety protocols you follow, what do they follow, are they trained to do it, and then keep a log of it. So we have contractor management, a very specific department that says contractor management. Where I work with, I actually deal with third party inspectors, like inspection inspectors. So they need a particular certification from American Petroleum Institute. If they're going to inspect their pipe, your pressure vessels, relief systems, they should know what they are doing, right? And so if you're sending people offshore, like if in the platform right in the middle of the sea, they're not the same as people who are going to go in ground. They require specific training. They'll call it the inside water training. They'll have the OSHA training, few key specific trainings on them. And then if you're working in above water, like say some of the pipings that are in the water, you say we'll call three people, three party person. Like one will be certified in level 2 inspection. They'll have two other people working on it, and then you should have three people if somebody is above water. So there are a lot of specifics that happens when you have third party people. And logistics is very important. Mainly, like if you're going into a plant, right, there is a specific amount of people they can actually handle. Because if there's anything going on, they need to know how many people are inside the facility, right? Muster points. Why do they have muster points? Like they keep a log. Oh, I had 50 people enter the plant, all the 50 people are taken care of. If contractors are coming in, as simple as parking, we are support whenever you get into a facility, you park backward when you get into your car or anything, right? Because quickly you can come out. There is no more parking in the front, you reverse park. So things like this, you have to educate them. If you have a hydrogen sulfide monitor, who knows? They don't know. They have to get into the office, those contractors. Okay, have a contractor log. Okay, everybody is given this. So things like that. Have they done their job safety form? Have they done their job hazards form? So these are the things that when you have third party people within your company, because they're not aware of what your company policies are, your compliance things are, right? So to educate them. So contractor management is very big, like logistics and everything. Then moving on to pre-startup safety review. So pre-startup will happen in multiple situations. So first, when you're installation of a plant and then you're going, you have a pre-startup, because you're going to first, send everything in it. You don't know if everything is working, right? So you have protocols in place. So what do we go over there? Construction and equipment are in accordance with the design specifications. Check. Okay, this was done. We check that. safety, operating, maintenance, and emergency procedures are in place. Yes, there's a startup procedure that we follow. You just cannot start everything like that. Every process, every individual equipment, piping, relief device, they all have a specific way to start up. Sometimes they'll say, hey, this has to be normally closed, this has to be normally open, this valve has to be open, this has to be closed, only then you can go. Otherwise, it's going to go, elsewhere. So things check up like that. And the PHA has been a pre-startup PHA is usually done to make sure everything is in place. Modified facilities meet the management of change requirements. So like I said, over the age of a facility, it's not going to remain the same. They'll add new process, they'll add new equipment, they will change people. They change the operating conditions. Sometimes they even change the chemicals. They might add injection points. They'll add chemical inject stuff like that, and everything is going to change the dynamics, right? Even a small, like if you go a little bit beyond a particular temperature, your whole dynamics changes in your plant. So is everything documented? Is it going to produce anything new? Like every change is not going to be for good. Some changes can also, increase the risk. So things like that is taken. Is every employee trained? Anybody who's going to start the plant, is he trained? So all these things checkup come when you do a pre-startup safety review. Then mechanical integrity. So that's where I have been working for a long time, right? Like I started telling you, hey, you design a plant, you have a lot of safety systems like your relief device, your instrumentation, your they call it your control valves, then your DCS system where it feeds all of this. So what are those systems there for? They decide, they detect, they deflect. So first it will detect something is going wrong, because everything is not going to be perfect, right? If there is some high pressure, you're going to release something out. Is it detecting? Does it decide what to do? Oh, it's going, if there's control valve, something, oh, this pressure changes, I'm going to give a signal to there. That signal will increase something. It will give an alarm, and that alarm, there is a response to that alarm. My operator will say, hey, I'm seeing a high alarm here, I'm going to go, I have a procedure to follow. So and then it deflects. So it will reduce that situation. It will bring it back to normalcy, things like that. But how do you know it's going to work? That's where we come in, like the mechanical integrity. It's called inspection, testing, and preventive maintenance programs. So what do you inspect? We inspect the piping. So we have techniques like ultrasonic technique, radiographic techniques, and PEC, like pulse steady current, lot of techniques that can shoot things and say, hey, within your pipe, I see there is, it's thinning out. There is a pit forming. There is something going on. So it's just a diagnostic material, right? Something is going, it's more than diagnosis. It's like an indication. So when you get that whole thing, every 5 years you take it, you can do a modeling. You can do like a trending. Oh, this piping looks good, but I see here, I can see something. Then you go to the next level of it. Okay, I'm going to do an analysis on it. What's going on? Do like an anomaly management. I'm going to list all the anomalies. It's beyond my criteria. Like every company will have its own criteria. For example, when we think if there is a pipe and it's starting to thin, okay, I can, the pressure inside it, I can retain it up to a certain point. Beyond that, it's going to increase your, the thinning. And then at one point, I'm going to have a rupture, right? But who is going to take care of that? Who's going to do it periodically? So there are different RAGAGEPs. RAGAGEPs are like registered and generally accepted good engineering practices. And some, what do you call, like, jurisdictional requirements codes like ASME code, where particular thing has to go this way, and OSHA, right? All these things help you to do these inspection techniques. So keeping it, and what typically we see, right? They will do the inspection when they install the plant. After 10 years, they'll come back, oh, this rupture, this went wrong. We didn't look into it at all. And then when they go back the next 10 years, it's a mess. Or they don't document these information, they don't trend it, they don't analyze it, they don't take action items. That's where evergreening comes into picture. So everything is in place, but what's the whole point if you're just going to leave it there, right? You come back to it, you revisit, you make actions out of it. Hey, I find this thinning, go, what is the damage mechanism going on? What can I do? Can I reduce the temperature? Can I change my process fluids little bit, bring it down? Can I add injection, like can I add a chemical inhibitor? Can I increase the inhibitor so that I remove? If I can I better the process? At the worst stage, what you have to replace the pipe. Can I do that section of the pipe? Can I replace it at this moment before it becomes a loss of containment? So those are the action items we typically do in the mechanical integrity program. Then moving on to hot work permit. So lot of processes have flammable spots, right? Not everybody knows it because the whole plant is not flammable. So you identify, you have specific identification for those. When you have third party people, how do they know what is it? So you give a hot work permit for them. So these things have to, is important because lot of issues, like not a major thing, but personal issues have happened because they don't have a hot work permit. They don't have a lockout tag out. They don't know what they're getting. You enter into a closed vessel, right? You should make sure that that person is trained in the lockout tag out. They know what is it because they might have a particular respiratory mask that they need. There is a specific temperature beyond which the oxygen level might be low. Those things you write. So similar, like a hot work permit is important. Management of change, that's a major thing. So say for example, they find an issue, they change it. Do they evaluate what the change does? So they call, whenever there is a protocol for a management of change, they do a replacement in kind or not in kind. So replacement in kind is like, say I have a piece of say I have a piece of pipe or anything. There is an issue with it. So say from the mechanical integrity standpoint, I say, hey, it's very thin. If you're going to run it for another 6 months, it's going to rupture. I would recommend you to change, especially if it's a high, like, if you have gas liquids, high pressure liquids, high temperature, depending on how hazardous that material is, what safety criticality it is, we will go for a change, right? Sometimes you change the same materials. When you do that, it's not going to change much. It's not going to change your dynamics much. It's not going to change your pH much. But sometimes say, hey, I want to upgrade this materials. I'm going to go for a different material. This looks like better. At that point, you have to go through a protocol of management of change, because what is the basis for the change? How is it going to change? What is its impact on safety and health? Am I reducing the inherent hazards? Am I going to increase the hazard? Because sometimes they'll say, hey, add this. I can add this, but that itself will produce a new hazard, right? So all those things you have to analyze, you have to brainstorm and document, and then put it into the system, and then you roll it out. So necessary time period for a change, because it's as simple as it to say, I'm going to change something. Say there's a heat exchanger, the tubes are ruptured, I want to change the exchanger. You know what the logistics is? It takes about anywhere from 1 to 2 years to even replace it. What's the money? Am I budgeted for it? Does my my team have that budgeting? Will I be okay for it? It's very easy to make a action item, right? So typically when we sit in the hazard operability, right, the PHAs, whenever there is a recommendation that comes in, all the eyes will go wide. Like they'll try to shut it down, because for them a recommendation, to implement a recommendation, is so tough because it involves the different levels. It has to go through different levels, and especially if there is if you have recognized a high hazardous situation for a recommendation of change, it's going to attract the eyes of all across, right? Because it's a high risk. So things like that. So management of change is now coming up. So lot of systems like SAP systems, PCMS, they all tie into the management of change. So there's the MOC system, MOC PHAs and stuff like that that usually goes. Authorization requirements, like I was mentioning, it's not very easy to authorize a change. You have a lot of questions asked. You have to present your case to the corporate for them to budget, to logistics and things like that. Incident investigation, the worst case, something has happened. It could be like a leading KPI or a lagging KPI. When I say leading and lagging, leading is it could have gone to a rupture and like an explosion, but you have not reached there. But then that's an indicator, because something is wrong, something is not working right. So when it has gone to the worst case, okay, you have had a rupture, you have had a tube leak. Now what can you do? Yes, it has happened, you have fixed it, but there is a learning to it, right? So you do a root cause analysis, different type of root cause analysis, like you do fishbone diagram, 5 eyes. Hey, why? You assemble a team of people, like who was there, and then maybe a process engineer, a subject matter expert on that particular process, people like that, like, and then go over this. What can I do better after this? Then if there's a very complex process, you do a failure mode effect of an analysis, failure mode effect cause analysis, so that you prevent it next time, right? And then some of these go into documentation for other industry. If a new industry is coming with the same process, what do we do? Where do we go for the basis for the documentations, right? Like the historical documentation, every time we come up, we look into the hazards, we always say, hey, you remember, right? We have the same process. Something went wrong in that industry, in that particular company. Let's not do that. So, when we were talking, we was like bolting, as simple as bolting. The dissimilar metal bolting itself will produce corrosion, and at some point it will just break, right? But they still do that. right? So when you have the experts who have that knowledge, when they come into it for an incident investigation or hazard analysis, they'll say, hey, you know what, in my industry they did this, it didn't work out, can we replace it, can we change it? So incident investigation, this is also a regulatory requirement, because something has gone wrong. OSHA is going to come in and going to ask you, hey, you were covered by the 14 elements. If everything had been in place, you shouldn't be having this incident. Chalo, we have that incident. What documented? What went wrong? What were the aspects went wrong? What are you going to change after this, right? So that's where the incident investigation situation comes in. Then emergency planning and response. So it's not, nothing is foolproof, right? Like I said, there's an age of these, the age of the facility, how it was designed. Sometimes you cannot have the best design, right? Not everybody has the budget for getting the best materials, and sometimes it's not needed, because say my life of a facility is 20 years and I'm gonna call. I'm gonna call. Sorry, I'm gonna call. Where's my laptop? I believe he's gonna come back. Oh, ask daddy for a phone. Yeah. Sorry about it. So so when there is an emergency going on, how do you know to respond to it? So there was an incident I was reading about where a fuel tank got into fire. There was no emergency planning to it. People got into the hazardous zone and then they were engulfed in the fire. So even if there is a fire, right? Not every fire you're going to go and attack it. There is a specific limit that you have to be. Say for example, you have a hot liquid coming out, you can't go and change it, right? You need a protocol. Hey, I need to wear these gloves, I need to wear my hazmat, if it's a hazardous material, hazmat specific coveralls, my things, and only then I can go. Then I need to call them. What is the response time? What is the amount? Say I have a hazard, this is the quantity of the flames that's going to come. How much water am I going to bring? How much fire engines am I going to call? Which is the nearest fire engine that I can call, right? The fire department. Whom do I inform? All those things comes in the emergency planning and response. So there have been situations where improper emergency planning and response, sometimes these are the things that people don't take importance in, right? So executing this, keeping them, somebody to go revisit it, hey, there's something changed, is there a new emergency response that I have to add, is there a new process that requires an additional emergency planning, things like that. Compliance audits. So we are, see, if everybody was working perfect, then I think there wouldn't be anything going wrong. Most of us won't even have a job, right? Like me, only if something is going wrong I have a job. But again, as men, we all, the tour is human, so it's not a foolproof system anywhere. So what can make sure that we are going in compliance audits? You do a program, but you never know. Inherently, it can have an issue. Subconsciously, you could have an issue, or just the nature of the company itself, right? Their poor safety programs, or maybe they are not aware of certain things. It could go wrong. So at that point, you need an audit. There are two types of audits. You could do an internal audit. There will be a third party audit. So internal audits are for you. Every 3 years, say I have every 3 years, there is going to be a third party outside audit. Every 2.5 years, I'll do an internal audit. So make sure, hey, I have everything in place. If not, I have this time to fix it. So audit is so important. Compliance audit. So people usually look at the compliance side, but to me, safety is when you do your things right when nobody is watching you. That's what safety is. But unfortunately, when there is a third eye looking at you, that's when you want to get everything. And then when the audit timing comes, people will start waking up. Hey, let's do this. Let's do this. But if you have a good corporate safety program, inherently it has to be good. That's what they call inherent safety design itself in process industries. That's the best thing that you can do when you're going to change. Inherently safer your process, right? Similarly, audits are so important. Every 3 years or every 5 years, usually you have audits that come in, and always audits find out issues and action items. Sometimes the company is good enough, they record the action items, follow up, and then they work on it, right? Then trade secret, it's just that sometimes with trade secret, people may restrict circulation of key information, but OSHA says that if it has to be disseminated, then but you don't have to get into any violate anything. So these are the 14 elements of the process safety management program. Multiple opportunities for a lot of chemical engineers to work on each of these, on different aspects of this, right? And to me, it's a great framework. If we can at least implement 80 to 90% of it, we can avert a lot of disasters. We can make the environment very safe to work. So what is a good process safety? We have everything in place. We have a lot of guidance. We have a lot of RAG gaps. We have compliance, jurisdictional regulations. But when the organizational culture itself promotes process safety, right? Everybody follows it at every level, small level. You be an example. You set an example. When you go to, as simple as when you go somewhere to it, hey, this is not safe. Can we change it? Just a quick glance, cursory glance helps you. Document it. Keep it for you. You can educate other people, even within your home. If you see anything that's unsafe, educate it. Say, hey, don't do it. Instead of just telling our kids or other people, like our natural response, hey, don't do it. No, but tell them the reason why you don't want to do it. Tell them what could potentially come through, what has happened in the past that you have seen. So at least it educates them. Children, they to me, my daughter, if I tell her don't do it, she's not going to listen. I say, hey, Sammy, don't do this. This is what is going to happen. Even then, sometimes they don't listen. They will just go and experience it, and then they come back and yes, you were right, mommy. At least the next time she's going to tell her friends, educate. So that is what like a good organizational culture is. And again, I said, when you follow safety when nobody is looking at you, that's the best form of compliance, right? Good communication, keep all in track. MOC, management of change processes, regulatory compliance. We trying to be compliant, that's part of it, but even inherently be compliant. Evergreening your processes, like I said, you have a process in place, but you revisit it. They call it the plan, do, check, act, like the PDCA. Simple. You plan it, you do it, you check, but you act on it. You check it. You have some issues going on, you try to fix it, bring some action items. Sometimes you can prevent it, sometimes you mitigate it. KPI tracking. So you come up for every program you have, come up with key process indicators. How can you track for yourself thing, right? You say, hey, today I did this. What all can I do? How am I good at this, right? So you do some performance indicators, track it. For example, in process safety, we have the API 754, it's called process safety performance indicator, like RAG gap. Lot of good thing. You keep scorecards, you evaluate yourself, you better it, right? And budgeting visibility in corporate. So typically it's very difficult, like you have to budget for all these things. So hopefully you have a good corporate process safety team that helps you. Inherently safe processes. So that's where the key is, right? Instead of fixing everything later, like I said, it's very difficult. If you can identify it in the design phase, the pre-feed phase, it's easy. It might cost a little bit more, but down the track, you are going to reduce your maintenance. You're going to reduce your hazardous explosions. You're going to reduce cost if there is going to affect your personal, your branding. All those things come if you can move into inherently safe. Like say, inherently safe is not just the materials, right? Okay, if I can use an alternative chemical for it, I can use an alternative temperature situations, I can reduce the amount of inventory I'm going to have, I can change the design of the process, I can use a new process itself, right? So a lot of, for example, in the pulp industry, initially it was chlorine, now they have moved to non-chlorine processes because chlorine inherently presents hazards, right? Things like that. Employee safety is given importance. Like PSM's first, employee participation training, you give them importance because they are the face of you. They are going to implement it. One small issue, like disasters, like operator actions, that can cause a disaster, right? There is now a whole new thing that's called human factors engineering because for example, say there is a main operator, right? Here, typically they work 12-hour shift. Say they come at 6 in the morning, they are like 12 hours. There is always a fatigue issues, right? Say you're going to give him a 10-step process every 3 hours. You want to revisit it, right? Can he do it? Or maybe should I put two people there? Is that person able to do it? Does he have the time to do it? Does he have the bandwidth? Is he given all the situation to it? Is he say he has to walk like 10 minutes for to change something goes wrong, and then the response time is like 5 minutes. Is he able to go in? So he's going to run. He's going to panic. It's going to reduce his efficiency. So human factors is now a very, very new thing that's come into process safety. We have human factors engineering, human factors engineers that participate in PHAs, right, to understand. And see, even you can model, simulate assets and the non-living things, right? But living things is very changing, with dynamic. You cannot. Every person is different. You cannot model it to the greatest extent. So understanding what the best it can happen. So all forms of communication is well maintained and supported by the company. So documentation process is very important because sometimes when you do process safety information up, like PNIDs we keep redlining. I have my first job was to redline. Is just walk down a plant and then update. Hey, this your PNID will show one story. What is there will show a different story. There was so many things that we had to change. But that you'll think, well, how is it going to? No, it's going to change, right? Because I have an additional valve. That valve is probably an open or closed valve. What if it was open or closed? Unless I have it in a place, I can say, hey, this PNID, this valve, it has to have follow this. This is the position for it. Say it's a control valve. It is a position for this. I document. There might be a procedure associated with it. There might be a training associated with it. There will be an operator who might have to see. You see the connection. So process safety information is there. You document it. If something changes, there is a revision to it, right? So things like that are key for a good process safety program. So I know there's a lot of technical things that I've talked about. Is there any questions or anything that you want to add, Nattu sir, before I get into some opportunities that these girls can pursue? Hello? Is there anything that you want to add? I'm just going to move to give them some idea of job opportunity.
Yeah. See, one query is, do we say that most of the accidents are due to human error only?
No, not necessarily.
Okay.
So it's see, that's the thing, right? Not there are lot of human errors, but that's not the only thing that goes wrong. Everything can go right, but then something inside the process that's not working, like as simple as there is a contamination, or we have not picked like a particular spot that we inspect that we don't know is corroding, and then it comes out, right? Like there is no foolproof, but lot of events can be averted if the human interaction is better. So human factors is important because even now not everything is automated, right? We still have manual operations, manual operators, operations people there. So human factors is a new topic. They're trying to better it so that better that whole process, so we can actually that element of error can be reduced. So
Do you think more of artificial intelligence will get into process safety business?
it might, but it depends. If it's a new facility, it's easy to integrate. But then existing facilities that are still running on older process, older things, I don't know how easily they can do an artificial intelligence integration. And not it's there is not bandwidth to completely do everything into AI. So we still need to evaluate because it's new. You would need some pilot operations to run and see if it's possible. So AI to some extent, yes. For example, if we have automated ROVs that go into like high pipeline rigs, right, for inspection, you don't have to go there. They do it, and AI, like on the spot, you can get information back into your thing, so that you're reducing your exposure there, right? But again, there are challenges associated with it, the cost associated with it. So not everybody can go for it, right? So it's still to be considered. It's good to be considered, but there should be a lot of research and pilot opportunities that go into it before they can completely put it to it.
See, being a mechanical integrity in charge, do you monitor the entire pipeline length of the plant, see for crack, fissures, and all those stuff, or
So
leaks and
I work mostly with the top sides, like pipeline is, I'm not into pipeline integrity, but I'm into pipe and pressure vessels and stuff. Yes, the entire plant. And again, it all depends on how your customers want it. So for example, let's say typically the whole plant is covered, but you have like utilities, they typically say, hey, I don't want the utilities in it, because utilities are like demon water, cooling water, and things like that. They usually don't. And for them, the return on it might not be that much, but it's equally important to look into that also. Like you do a PhD on a cooling water facility because just to make sure that you have everything identified. Yes, for integrity, we go through the entire process, all the pipelines, the relief systems, the pressure vessels. We look into it. We do inspection. So we usually hire inspectors. I'm not a certified inspector, but we have piping inspectors go in field. We use like diagnostic testing, like the ultrasonic testing, radiographic testing. So we get the thickness of the pipes. So there's a whole lot. First, what you do is you split the whole plant into circuits. Like we'll say, I have produced water, I have diesel fuel, I have heat medium, I have cooling water, I have gas, processed gas. So different systems. So you circuitize it. Then for each circuit, based on what the criticality, the risk associated with it, I will prioritize the thing. And then I don't, when you start, you do a baseline. I get a baseline of the entire plant, right? The whole, like every point, you choose points. They call it they call it corrosion monitoring locations, or inspection, TMLs. They call it thickness monitoring locations. So every elbow, I pick a point. Every high point, falling downs, then bleeder valves. On a straight pipe, say I have like about so many foot of straight pipe, how many points should I take? There are specific procedures for that, even choosing, optimizing CMLs. Every fit, I have an entire line circuit. I can say I'm going to choose 50% of the fittings. And if I have dead legs, like where points where I see that there is going to be like materials stagnant, that's going to accelerate corrosion, I'm going to pick points. So things like that. There is, just to do that particular location optimization, we have procedures and policies. So as small as that, to executing a risk-based inspection program, and so that's what I do. And but for most of the in-field inspections, I hire inspectors, I manage inspectors, third-party contractors, and people like that.
What are your working hours like?
So
Daily
if
schedule,
you are in the office as an engineer, mine
would
is
you be in
usually
shift,
8 hours.
etc.,
Pardon
or
me?
would you be in shifts or
Shift people, here, when you do, like if you're in the onshore facilities, it's usually 12 hours. They'll start at 6, and then no, it's probably 9 hours, I would say, 6 to 3 or something like that. And then 3 to the, if it's like a full-time facility, like 24 hours, that's how they do it. When you go offshore, it's usually a 12-hour shift. Like when you are sending inspectors, it's a 12-hour shift, like in your middle of the ocean, right? It's 12 hours. And I think, yes, but we usually don't go beyond a certain 3 weeks, campaign or things like that. Because, like I said, right, human beings, you need to make sure, because your reporting is going to go off where once they start slowing down, you might not be that the effective, your quality will come down, things like that will come down. So we keep a tab. And like if I send out my inspectors, they start at sometimes 6 in the morning, go up to evening 6, 12 hours, and then they come back. So, and then we have a debrief every evening. And then I ask them, "Hey, are you all okay? Is everybody okay? Did we have any issues going on? Do you think you need to fly back, to come back? Are we good? Do you think it's going to extend beyond this point? If that case, I will have to shift you with a new inspector," stuff like that. So here, typically, it's 12-hour. The regular engineering job, 6 to 8 hours, I would say, depending upon the load of your work. If you are in field, it can go up to, the rotations can go anywhere from 9 to 12 hours.
okay? So thank you. Any students, any question? Anyone else?
I
Okay.
would just quickly just let them know. So the different type of roles that they can go is, you can become facilitators, like hazard facilitators, scribes, go into mechanical integrity, like get certified in APIs for piping inspection. So in field inspections, you can even, abroad, it's a very good, it's a little tough, but then it's a good opportunity. Instrumentation engineers, who design all these instrumentation control valves, and then like links to it, like stuff like that. Occupational safety, which is also a good thing, right? Reliability engineering, inspection engineers, you can be auditing, like third party auditors, you can be certified in auditing. You can become compliance engineers, corporate compliance, so you know how to implement. Human factors engineering, like I said, is a great thing. Operations, if you just want to be in house, you can be designers, process designers. Fire protection, these are all lot of opportunities that, if you want to get into the core engineering field, you can try. And there is always going to be some form of opportunity in all of these aspects for you all. So um, it's it's a great field. If you like chemical engineering, I think it's you have a lot of opportunities. And I don't know how it is in India, how things have opened up for women there. Because to me, when I was in Pilani, I think hardly any chemical engineers, women got into the core chemical engineering field that I know. But at least I would say, if any of you, I don't know, sir, in Indian scenario, I don't know how it is, but I think that it's increased, it's progressively increased. At least being an engineer, a desk job, like if you're in your instead of going into the plant, there is there is still the risk of safety there, because the ratio of a woman in the plant when you are in field is still low than compared to your office jobs, right? So it's, I would say, start with the office job. Occasionally say, okay, I would like to go for a walk down. I would go like like a overseer for a particular job to understand what it is, right? And then if you see, like if there is hundreds of men over there, there'll be like two women working over there, but it's still, they're still, it's still, there is a lot of room for changes there.
See, over
So
the last few years, the chemical industry has become more open to recruiting women. Uh, Companies like Vedanta Group, Aditya Birla Group are visiting Banasthali
promoting,
campus to recruit women
that's
chemical engineers. I
that's
think
good.
it's opening up. I do agree that yeah, 10, 15 years back, during 2000, etc., the chemical industry hardly touched. I know that none of the core companies even used to come to Pilani for campus placement, but that is the change now, right? And they are recruiting more. I think they have got a mandate to raise the women workforce from
Uh-huh.
almost single digit, which is now 5 to 8% still,
Awesome.
to over at least 30 to 40% in the coming few years. So I am
See,
sure that
right.
the prospect for the women chemical engineers in the industry is rising for sure. But for all the other economic, issues.
More than economic issues, the accessibility is the biggest thing, because most of these facilities are remote. Even getting a signal, even in the US, getting a signal in those facilities is so tough. So even if something is going, so personal safety is so important. Even if you're going into this, keeps make sure you're aware of your surroundings. You get somebody into your thing, and emergency thing, numbers in hand, right? Because it feels very weird when you are there in a lone facility. Sometimes even your phone doesn't work, so be cognizant of that. But I'm glad to hear that more women are getting into it. It's a great field, I would say. As much as IT and other easy things, this is very, very challenging, difficult to sustain, but it's well worth it. If you really love chemical engineering, this is a great industry to be. I
Okay.
I love my, every time I'm into a hazard or like doing mechanical, I like it. I enjoy it. That's why I was in IT and I said, no, that's not for me. I want to get in. So if you all sitting in this call, at least I'd be great. At least if 10 of you are into the core industry, and maybe 10, 15 years from now, I never thought I would be giving a talk for you all or for Nattu sir. But today here I am, just because I chose that I'll get into the chemical engineering field.
See, when you joined Wipro, etc., after a bit, I thought, no, one more chemical engineer lost to
Last,
the IT job. But I'm happy that you have come back to your passion, and
yes.
I'm sure your words have kicked up the.
And I have to tell you this also, the remuneration is also great if you can do well. It's not
Yeah.
that IT is quick money, but if you sustain in this industry, the amount of subject matter experts or people is very less here. So if you can sustain, it's a great industry. And I personally don't know about in India, but abroad also you have a lot of opportunities to pursue, and lot of new technologies, that there are a lot of room for like AI that he's talking about, new designs, all, so many things that we can get involved. And I greatly suggest go into it. It's great. It's something different that you're doing.
Thank you so much. Request all to give a big hand to Sunita. So wonderful, and many of them may not know that you have a 15-month-old child who is sleeping probably and will be
He's
getting up.
already screaming there. Thanks to my husband. So I should not discredit him. Without the support of family members, it's very difficult for women to actually, pursue. So the key is also to make good choices in your friends, in your spouses, in your family. Get them into confidence when you have to, go in for a successful career path. That framework is so important for you. That is also something key.
You will also be surprised to know that among the women universities in India, only Banasthali is offering chemical engineering. None of the
So
other
awesome.
women universities are offering chemical engineering.
You are there, sir. I know it's going to be
Let's
great.
see. Okay. Thank you
It's in
so
great
much.
hands.
And, have a great Sunday. And it was nice meeting you all over again. After
Thank you so much. My pleasure. You
thank
all
you.
have a good evening.
Yeah. Thank you. Bye. Bye.
Bye.
Here, stop recording. I have recorded the proceedings also. I will send you the link.